Good afternoon, everybody. So welcome to day 2 of Android Summit. My name is Xandrioji, and I am your Zoom room monitor for the session. I won't take up too much of your time, so Manuel, take it away.
Hi, thank you everyone for joining. I'm Manuel Vivo. I'm an Android engineer in the developer relations team at Google. And actually, I'm a former Capital One employee as well. So I'm very excited personally to be joining here and being here with you today. So today's talk is gonna be about coroutines and Android. So let's take a look at the agenda. So the agenda is gonna tell you if you're in the right room or you have to go and see another talk. And it's also gonna help you, or it's gonna help me to force you like hang around and keep listening, because I need to convince you that this talk is worth it. So we're gonna see the current state of the world, like what role coroutines is playing in Android. We're gonna see how coroutine is made for library developers. Basically, you are a library developer, so this matters to you as well. Also, a little bit of a comparison between LiveData, Flow, StateFlow, when to use which, what do you need in each layer of the hierarchy. And something that I'm very excited to share, it's what's coming next. And obviously, lastly, we are gonna talk about SharedFlow just to finish the session. So as probably you may know, async task was deprecated in Android 11. And there we have some like cryptic messages there in the documentation, but there are a lot of alternatives out there. So taking a look at them, some people have turned like to using various custom solutions, like involving threads, executors, that there are valuable options, or higher level libraries such as RxJava or Guava. And now in Kotlin, there is one more contender, and that's of course coroutines, which is our recommendation for Kotlin applications. So we recently announced that coroutines are the recommended solution for asynchronous code on Android. And for some time already, it's been our focus to explore and deliver solutions based on coroutines. And in that way, like we are promoting new APIs, samples containing coroutines, code labs, and documentation. In fact, many people in Android are falling in love with coroutine, but why is that? So I tried to keep the list short because we are gonna discuss some of it in more practical samples. However, the unique properties of coroutines make it especially well suited for Android. So we have structured concurrency that is gonna help developers scope their work to the application components lifecycle, and it's also gonna help you preventing memory leaks. Then we have callback-free top-down code that is much easier to read and understand. We also have cancellation support and natural exception handling that make a great addition. And finally, many coroutines can run on a single thread, suspending their work instead of blocking, sorry. So it's gonna make them very fast and lightweight. And the Google team in Android believe in coroutines so much that we decided to put them up on our redesigned website as the 4th top reason to adopt Kotlin in your Android application. So check this documentation out if you haven't seen it already. Many of our APIs already support coroutines, as you may know. So to enter the world of coroutines, we've created special-made coroutines scopes that allow you to run async code inside view models and lifecycle owners. And within these scopes, you can make use of the coroutine support in various Jetpack library. For example, Room, Work Manager, etc. We'll cover more of this in a little bit. But both of these extensions are extensions to existing libraries. But in some of our new libraries, we started with coroutines from the ground up. For example, that's the case of our new Paging3 library that uses coroutines like all the way up. And now we're gonna see Work Manager as example to kind of convince you that coroutines is the right solution for async code in Android. So we have here the worker, which is the most basic one, the most basic API for Work Manager. And then it's gonna call this do work method on a background thread. And so here you can do blocking operations like reading from a database, uploading to a server, and then writing the result to a database again without worrying about blocking the main thread. So at first glance, this code actually doesn't look too bad. It is easy to read and very explicit in what it does. But one of the problems is that we are only allowed to do synchronous requests here. The moment you need to use an async API or parallelize calls, it would get really ugly. Another problem is that the work manager can stop the execution of this work at any moment. And so now you have to do like if else, or like checking if something has stopped executing, or we have to stop executing or not. So this actually doesn't look that bad, but imagine that, for example, in upload to server, it is a very long operation and does much more things, like more complicated things. How are you gonna stop, how are you gonna pass this stop signal to that call? It's practically impossible, and it's gonna make the example much more difficult. So this example leads basically nowhere. Although you can see that this has natural exceptions and easy to read top-down sequential code. So let's try something else. Let's try another API. So for example, Guava. And here we have the listenable feature from Guava that we can use as an async solution. And for that, we have the listenable worker that also supports this Guava library. So here we assume that we have some background executor or type listening executor service, and we submit some of the work using these functions, they transform async. Then it doesn't look really nice, does it? Because you submit to it, then you get another feature back. You have to use transform async again. It is not ideal, because look at how difficult it is to actually read the business logic of your application in that code. Even though the solution has cancellation and error propagation, it is not perfect. Then another solution is RxJava, of course. So here, for that, we have in Work Manager the Rx worker, which is available. But it comes with some drawbacks as well, such as you have now to learn all these RxJava operators, and simply the solution cannot escape the Java programming language's limitations, like having to chain the calls, making everything less readable. And then finally, we get into coroutine land with the coroutine worker. And basically, we have here this do work method, and that's it. We have this top-down sequential code, and we are assuming that our database and HTTP client are going to provide suspending versions of their APIs. So it means that's going to suspend all the way down. So everything looks sequential, readable. Cancellation happens more or less automatically, because that was handled by the library authors that we will see in a second. And errors also propagate natural. So you could see, you could think that coroutines are actually quite simple, but in reality, they are not. They are an elegant solution, but it could get really complicated. So what I would recommend for you and your team is to educate. So we have here a bunch of links about coroutines. So we have different blog posts to see how cancellation works with coroutines, exceptions, a suspend modifier, how it works under the hood. We also have a bunch of codelets that help you go, step by step towards learning how to use coroutines in an Android application. And something I said before is that coroutines are really easy if we all are library developers. And what does it mean? And with a library developer, everyone is a library developer. Even if you are working in a team of 3 or 4 people, you will be pretty much in charge of something in your app. Let's say you are working on a repo layer. If you're working on a repository, you are a library author by the other teammate that is going to consume your code. So that we need to actually learn best practices and see, for example, how other libraries do it. And in this case, we are going to use Room as the example. So for example, Room, you can see that here it provides a suspend version of the API. And so that's going to make it like coroutines friendly. And for your APIs, you should pretty much follow the same pattern. And something that Room does in this case is that even if you call it from the main thread, it is going to swap to a background thread for you. You don't have to worry about that. And so in your API, you have to take that into account. You have to make your APIs main safe. So for example, here, the suspend function that we have as example, we are making it main safe because we are switching the context to be performed in the IO. So the library or your code takes care of moving the execution to the background thread and returning the result. And so now consumers don't really have to worry about it that much. So for example, if we were in a view model and we use the view model scope, like you could call launch or your consumer could call launch and use your API as if nothing happened. So make it the library's responsibility and not the caller's, because everything is going to work much nicer and you won't have threading problems. Another thing that that Room does well is that apart from moving the execution to a background thread, it also gives you the opportunity to change it. So for example, here we have a few methods like setQueryExecutor and things like that. And you pretty much have to do the same. So the thing with Room here is that it works with executors, but it is also a Java library. It is not like coroutine, it's not a coroutine only solution. But then you can see there are methods to exchange from a coroutine dispatcher to an executor or the other way around. And that's pretty much what you have to do in your APIs as well. You have to have a wave so that others can inject the threading that they want to use, or pretty much the dispatchers that they want to use. So apart from being able to reuse other dispatchers or other executors that your consumer might be using in their app, it is also good for testing. So in this case, if you want this suspend function to execute synchronously in testing, the good practice is to inject the dispatchers so that everything becomes much easier. And then the other thing that Room does out of the box, in Room you don't have to worry about it, but probably in other APIs you do, it's having coroutine adapters. Usually you won't be building your API from scratch. Maybe you have a Java-based library already, or you are trying to adopt a third-party API surface to coroutines. In those cases, you have two options. First, check if there is a coroutine adapter already available for you. So there is a coroutine adapter for listenable future, for task, etc. But then if that's not the case, if you have to build your own, then you can do it yourself. It is pretty easy. So for this, we have the suspend cancelable coroutine builder that you can use to resume the coroutine whenever like a suspension point happens. So here you have the resume or resume with exception methods that you can use in your code lab. So this is not like a final or full solution. So if you want to create your own adapter, I suggest you take a look at the code of any of the adapters in the coroutines library. So we've been talking about suspend functions that mainly mean I want to make a one-shot request, and probably I want a result back. So now we are going to switch gears a little bit now and talk about Kotlin Flow. So Kotlin Flow, it's going to extend this functionality by offering the possibility to model a stream of data, not just single values as a suspend function does. And the good thing about Kotlin Flow is that it builds upon the foundation of coroutines and suspend functions to inherit some of its best properties. So you have cancellation, structured concurrency, exception transparency, and even natural back pressure handling through suspension. So all good there. It gets all the benefits. So back to Room. So before we have a suspend function, but now we can make it return a flow instead of having the suspend function. So observing this flow, it's going to make the app react to changes when the database emits data. And you may think, okay, this is a stream of data, but we have other solutions out there. So we have RxJava, we have LiveData, we also have Flow now. So what's the difference? The difference with other solutions like RxJava, conceptually, they are very similar. They are not that different. The main difference here is that Flow is built on top of the coroutines foundation that we've seen before, with all its benefits. And those benefits, like some of them might be available in RxJava, but others are not. So make sure that Flow is a great solution in this case. But then how is that different from LiveData? If you go through our code labs, you will see that LiveData is used in the UI layer to observe for state changes in the view model. And the answer for comparing between LiveData and Flow is much more complicated. So let's dive into this. So conceptually, LiveData is a value holder. It always holds a single value that can be written to and read at any moment. So what follows from this is that when an observer connects, they will only see the latest value and the new ones that they are being emitted. But even though there might have been like intermediate values emitted in the middle of while the user or while the LiveData wasn't observing, those values, intermediate values are going to be dropped. They are not going to be seen by the observer. So what's important in LiveData is the current state. But then on Flow, with Flow, there is something different. Like a flow doesn't have a value outside of being collected. And it will deliver all the values emitted into it, unless it's configured differently with other operators, such as conflate. But in most situations, the UI doesn't care for any previous states. And so for that, like LiveData might be a good solution. And then Flow can be more appropriate in lower layers of your architecture, like for example, in the repo layer on the data source, where you cannot afford to lose some values. And now another player came recently into Coroutines version 1.3.7, which was StateFlow, or like the counterpart mutable StateFlow. And they are pretty much the same as LiveData. It also holds the current value. But the main difference here between LiveData and StateFlow is that StateFlow is a flow, and it has all its operators, and with all the benefits of coroutines as well. Whereas LiveData has some drawbacks, such as only being able to be observed from the main thread. But here, the thing is that you don't have to worry that much about it, because you don't have to pick one over the other. And it's very easy to convert between a flow or LiveData and vice versa. But now, since we are now a little bit worried about, is StateFlow going to replace LiveData, or what's going to happen there? Do we have to use StateFlow or Flow to collect or observe state from the view? Now I want to introduce the suspending APIs. That is going to make everything, hopefully, a little bit more clear. So in the Android lifecycle KDX library, we provide suspending APIs to listen for flows in the UI layer. And we're going to see in this section stuff to watch out for. So now in this example, we're going to see a flow producer that will send location updates. So similar to how we converted before a single shot callback to suspend function using the suspend cancelable coroutine builder, callback flow is a builder function that lets you convert callback or listener-based APIs into a flow. So here we take the Android's location API, which will keep sending us location while it's being active. So the source of the data, which is the location, is hot, because new listeners are not going to trigger the location API init code again. But our flow, the code that we have on the screen, is cold, which means that the builder block, this code here, will be executed every time this flow is collected. And so a separate instance of the location listener will be installed. So let's say we have this flow that we want to collect from the UI. We have the option, as we were saying before, of using LiveData. So if we wanted to use LiveData, you can convert the flow to LiveData using the asLiveData function and observe it. And then alternatively, you could listen for the flow using the flow APIs. If you don't want to use LiveData, you can use the lifecycle scope available in the lifecycle owners here. So we have lifecycle scope, and then the suspending APIs that I was mentioning before. So in this case, we are using launch when started, but then you also have launch when created or launch when resumed. So the thing here is that the coroutine will be executing when the lifecycle is in the started state, in this case, but will suspend when moving to the stopped state. So what's really the difference between observing a LiveData in an activity and collecting a flow when the activity is started, using launch when started? So the first one, using flow as LiveData, it's going to cancel the flow collection when there are no active observers, which means when the activity is in the stopped state. So it's going to cancel that observation. But the second one is going to use a pausing dispatcher, which is going to pause execution when the activity is not started, but only cancels the coroutine when the activity is destroyed. And so whenever the activity goes to the stopped state, it's going to suspend the coroutine, but it's not going to cancel it. And now this is something that you have to keep in mind. So when the activity is visible, the collecting coroutine is active and it's going to update the UI, while the producer coroutine is sending location updates. But now, whenever you want to start another activity or sending the activity to the background, this is going to move to the stopped state. So the consumer is in LiveData solution, the collector is going to stop. It's going to be canceled, and so the producer will be canceled too. But then when using the suspending APIs, when using, for example, launch when started, this is not going to happen. The collector is going to suspend, but the producer is still active. So as the flow hasn't been canceled, the producer coroutine keeps churning in the background, getting locations and putting them into the flow, even though there are no listeners waiting for it. And so this is something to watch out for. And because this is quite important, I created a kind of a table for you to get some help on that. So here we have a summary of the things that I've said in a very tweetable way, and also added a little bit more information about what's coming next. So I'm going to be talking about a lot in this slide, so feel free to tweet about it if you think it's interesting and exciting. So let me start by the row in the middle, because that's what we've seen so far. So if you want a suspending behavior, because this is what your business logic requires, you can use the launch when APIs. And here, there is no alternative for LiveData. So there is no way you can suspend something in LiveData because it doesn't have that concept of suspending. But now, if you want the canceling behavior, you can use a LiveData because you can convert it using as LiveData, or you can do it yourself, because right now we don't have APIs available for you to canceling when the view is going to a different lifecycle event. So you have two options here. Either do it yourself with, keeping track of all those collections and then canceling them when the view go to the stop the state, or you have to wait, or actually you can use LiveData in that case if you don't want to do it manually, or the team is working on an alternative for this. So we know that this is a lack of operators or a lack of APIs from our side, from the coroutine lifecycle scope side. So the team is working on this as we speak. And so hopefully we hope to be sharing more news about this pretty soon. So that's for the suspending and the canceling behavior. And now I added another row at the top, which probably it's a little bit unrelated, but it kind of makes sense when you think about collecting from the UI. And it's data binding. And obviously you may know that LiveData is supported by data binding, but I'm so happy to announce that now we are gonna add support to StateFlow in Android Studio 4.3. So I'm very happy, I'm very excited about, because I've been personally involved in the implementation of all this functionality. And so we don't know when it's gonna make it. We don't know in which canary it's gonna be available, but I want you to know that it is coming. So we have a few things in flight. This is StateFlow support in Android Studio, and also the canceling APIs that we want to improve, that we want to add to the lifecycle KDX library. And so if you pay close attention, you will see that there is activity in the flow column. And this is because we don't know if we will end up supporting flow in data binding. So StateFlow, it's a quite straightforward implementation because it pretty much has the same APIs as LiveData as we were seeing before, right? So we have the get value and everything is pretty similar to LiveData. However, with Flow, we don't have any of that. And if we wanted to support in data binding, we need a major refactoring to know how data binding is reading observables from the ground up. So TBD, we don't know yet. Cool, so moving on to the next section is actually more about StateFlow in data binding. So as I was saying, this is pretty much work in progress, although the implementation is there. I've been testing it, it works fine. We just need a few approvals. And it will be at some point available in Android Studio 4.3, the next version of Android Studio. So in case you wanted to use this, how you will be using it in the future, it will be something like that. So now to enable data binding, you have to use the data binding equals true in the build features of your build Gradle file. But now, if you want to use StateFlow support, you will need to add the data binding KDX feature there. And now you would just use StateFlow as you use LiveData at the moment. So for example, you can import it in your data and then have a variable which is of type StateFlow. And then you can use it in your, in whatever the type is, you can use it in your layout IDs. In this case, if we wanted to set the text whenever the StateFlow emits new data, we can have it like this. But also, like, you can make it like as complicated as you want. So for example, we could have a StateFlow inside that StateFlow, and that's gonna work as well. Cool, I hope you enjoy the future whenever it's available, and all the feedback that you have to give us, it's actually very welcome. And the last topic I'm gonna talk about today, and then we can move on to questions, is about SharedFlow. So SharedFlow, it's an API that is gonna be available in coroutines in the future. So it is not available yet. So the previous APIs that I was mentioning, like data binding support for StateFlow or the canceling APIs, that's from the Google side. So we are working on that. But SharedFlow, it's from JetBrains. So JetBrains is actually working on this solution. And basically, it's being SharedFlow next to StateFlow was a very highly requested feature. So that in this way, you can have a flow and you can like share it between multiple subscribers. And in fact, StateFlow is built on top of SharedFlow. So it's a specific configuration inside SharedFlow. And next to SharedFlow, which is pretty similar to StateFlow, but with more flexibility, with a better and richer API, you have this sharing operator. And the sharing operator here, you have it in the slide. And basically, it helps you converting any flow to a shared flow by passing a coroutine scope. And so, for example, if you think about why this would be useful, if you think about the callback flow that we created before, it might not be that useful because, you know, here in that callback flow, we were just creating a new listener to register to the location API. However, StateFlow or SharedFlow in this case and the sharing operator are very useful in other situations when the flow is more expensive to create or you want to save resources by sharing it. And so if we wanted to use it with our previous implementation, for whatever reason, we would have something like this. So imagine we have the location callback flow that we had before, and we could use the sharing operator, let's say, for example, in a location repository. And now, as I was saying, like it needs a coroutine scope. And this coroutine scope is used to handle the life cycle of this shared flow. And so using, for example, something like an application scope, it will make the shared flow be shared for all collectors as long as this application scope is not canceled. So if you wonder, hey, where is that application scope coming from? Why is that not like, you know, a view model scope or whatever? So view model scope will be used, or like it's supposed to be used in the view model layer, but because here we are in a repo that probably is going to be used across the application, we could try and use an application scope in that case. If you are unsure about the implementation of application scope, you can check out this article I wrote a while ago in April, I think, for patterns for work that shouldn't be canceled. So that's going to give you an idea of what the implementation scope looks like. And then here in sharing, we also can specify the replay. It's basically here with our location callback. What we want to do is reply the last location emitted into the flow, so that when a new flow collector with a new observer collects from this shared flow, it is going to get that last emission. And then something that we have here that is very interesting is this started option. And here we are passing something like sharing started while subscribed. And which while subscribed option will free up the upstream producer whenever there are no subscribers. So imagine that all subscribers are gone, then it will gonna cancel that producer because it's no longer needed. So this is a very nice option that SharedFlow enables us whenever it comes. Cool, so as I was saying, it is not ready yet, it will come in the future, and we will have to come up from our side and from JetBrains side with patterns that make SharedFlow work better in the application. And that's been all from my side. Thank you so much. I'll be listening to your questions. If you have any other questions outside of this talk, feel free to reach out to me in Twitter or any other social channel. I'll be there available. Thank you for tuning in and for listening to the talk.
Awesome, awesome, great. Thank you very much. I did see a couple of questions come in, so I'll get started about that. Let's see. With Kotlin 1.4, there was a release of the Kotlin Coroutines debugger. However, it seems not to be working well within the Android Studio, only in pure JVM. Will there be any fixes for it later in later versions?
Yeah, I know that the team is been focusing on this, and for us it's also very important. So I assume this will be the Android Gradle plugin that needs to get updated and make it work with the debugger. So apart from the AGP, as you were saying, like we need to give it support in Android Studio, and like both things, AGP and Android Studio, I think they will get updated hopefully by next version. But I'm also looking forward to be using this feature in Android Studio.
Here, another question. When StateFlow is released and starts supporting data binding, will LiveData be deprecated, or maybe it needs to stick around for Java mixed projects?
Yeah, that's a good idea. So it will be there for sure. Like we are not thinking about deprecating it or anything like that, because Java projects still like need LiveData. It's a good solution still that you can use. And something that I didn't mention is that the data binding solution also uses the suspending APIs. Therefore, if you want this canceling behavior, you still need to either wait for our APIs to exist or do it yourself. Otherwise, you will need to be using LiveData if you want that particular behavior.
If you need to provide a library usable from Java, what alternatives to Flow?
Yeah, so this is something that we really want to update in the Android Guide to App Architecture. So you might seen in the past that at some point we recommended, and also, well, not fully recommended, but yeah, it was recommended. It was recommended, and then in some of our samples, that we've been using LiveData in outside the UI layer, let's call it like that. So LiveData is just made to be a communication channel between UI and vModel. But then when you keep LiveData out of that, it gets really complicated and it doesn't really work as you expect. So as an alternative, I would recommend people to, for example, use RxJava if they know already. And otherwise, like they are going to get into much trouble, because to be honest, there isn't a good alternative for something like Flow in Java at the moment. So I would recommend using RxJava.
Compose also has its own data holder for managing state, similar to LiveData and StateFlow. Any plans to unifying them?
This depends really on what you are trying to do with Compose. So as probably like you've seen, like Compose brings helpers to integrate with LiveData and Flow as well. And there isn't really a way to unify them because they are there in case you need them. But then Compose also has this now from Alpha 04 to Alpha 05, we have an API that got renamed. So something in Alpha 04, we had something called launch in composition, that basically it was pretty similar to this lifecycle scope that you would use in an activity. So that gives you a way to create or like create a coroutine in that composable context. Now in the new version, Alpha 05, that gets released next Wednesday, that's been renamed to launch task. But if you think about it, like launch task and something like an RxJava or LiveData or Flow helper, they do completely different things. So launch task or launching composition is going to be for work that needs to be done in the UI, whereas these other helpers are going to be for communicating or getting stuff from other layers of your hierarchy. So they serve different purposes. So I don't think we'll be unifying them.
Does lifecycle scope work the same in Compose?
Yeah, as I was saying, it's a different API. So Alpha 04 uses launching composition. Alpha 05 launched task is your composable to go.
Do you think StateFlow is going to be the foundation for Kotlin multi-platform projects with declarative UIs?
I can state my personal opinion here, and I would say yes. And this is because it is great, right? If you take a look at the API, even though it's in experimental, like it does everything that we need to do. And so like from the Android side, we still need those APIs to fully recommend it. But I think for multi-platform projects, another UIs that have a simpler life cycle, StateFlow is the way to go.
In the table, LiveData versus LiveData versus Flow versus StateFlow, are there any differences when the activity is in the destroyed state?
No, not really. When the activity is in the destroyed state, all of them all collectors are gonna be canceled, and that means that the producer will be canceled too, because the life cycle has been destroyed.
Okay, so another question: the difference between StateFlow on each and StateFlow.collect.
Yeah, this is kind of depending on what you want to do. So on each is an operator that lets you, let's say, it's actually an intermediate operator. Let me rewind. So we have collect as well, which is a terminal operator. That means that when you use collect, you cannot apply more operators below it or after it, if you want to say. But on each, it is not going to trigger the flow collection. It is an intermediate operator. That means that you can use it in the same way, but on each, it's going to help you apply more operators after that. So for example, like if on each could throw an exception, you can have a catch operator right after. And then obviously you need another terminal operator to trigger that flow, which usually it's the launch in operator, which is passing in a coroutine scope is going to trigger the flow collection, and they will behave pretty much in the same way.
All right. I don't see any more questions coming in, so I think we only have 2 minutes left anyway for this session. But thank you again. If there are any more questions, hop into this session's Slack channel. I'll drop the link in again one more time for you all there. And yeah, great talk. Thank you very much.
Yeah, thank you so much for listening. Let me know if you have any other questions. As I was saying, like I probably reply in the Slack channel or in Twitter, whatever you want. I'm so happy to be here again. Thank you for the opportunity. It's a pleasure for me. And thank you. Have a nice conference, you all. Bye.
Right on.